Hello everyone, this is question 7 on paper 2 from 2023 for Edexcel, and it's a nice implicit differentiation question. So it says a curve has the equation x cubed plus 2xy plus 3y squared equals 47. Find dy by dx in terms of x and y. Now notice it doesn't mention the word implicit, so therefore you've got to kind of like recognize from the context of the question that implicit differentiation is the way to go. And what is it that would help you to recognize that? I think principally the fact that you've got like x and y's in the same equation. So you've got one equation that's got like x and y's in, so therefore it's going to be implicit. So let's differentiate each of the terms and think about how we're going to approach them. So first of all, x cubed is just going to go to 3x squared. We've got xy, 2xy. Now remember that's a product, okay? So I've called the 2x, I've called that u, and I've called the y v. So again, you just, for the product rule, it's going to be u dash v add u v dashed. U dashed is going to be, 2x is going to go to 2, so it's going to be 2 times by y, and then it's going to be u v dashed, which is going to be 2x, and when you differentiate y implicitly, you get dy by dx. So that's our product rule used to differentiate the 2xy. 3y squared is going to go to 3 times 2, which is 6y, and then we add on a dy by dx. And the right hand side, 47, goes to 0. Okay, so now the question for part A is just to find dy by dx. So therefore what we need to do is collect everything that has a dy by dx on one side and everything else on the other. And I'm going to take out a factor of dy by dx. So here I have got the two terms, this term and this term, gathered together. I've factorized out my dy by dx. I've taken my 3x squared and my 2xy over to the other side, and then I divide by that. Okay, so I get my dy by dx is minus 3x squared minus 2y over 2x add 6y. So that's part A done. Part B then. Part B says the point P minus 2, 5 lies on the curve. Find the equation of the normal to the curve at P, giving your answer in the form ax add by add c equals 0, where a, b and c are integers to be found. So quite nice here. So remember that the two things that we need in order to find the equation of a line are a gradient and we need a point. Okay, we've got the point P, which is minus 2, 5. So we need the gradient of the normal. So what we need to do is sub in the x and y from P into our dy by dx to first of all get the gradient of the tangent. Okay. Then once we've got the gradient of the tangent, we're going to take negative the reciprocal of that in order to get the gradient of the normal. So the x is going to be replaced by minus 2 there, and the y gets replaced by 5, and the same here and here. So that gives me, when you work that out, that gives you minus 11 over 13. So we take negative the reciprocal of that, so that gives us a gradient of 13 over 11. And then we use the point and the gradient together with the y minus y1 equation to now find the equation of the normal. So let's have a look at that. So y minus 5 is equal to 13 over 11 times by x minus minus 2. It goes to x plus 2, then multiply everything by 11, so 11y minus 55 equals 13x plus 26. Where's that 26 come from? Oh, 13 times by 2 is 26, because the 11's already over on this side. And then I've just got everything into the required form. ax add by add c equals 0 is our required form. So it's going to be 13x minus 11y plus 81 equals 0, which is our answer for that one. So really nice question there on implicit differentiation. Hope you found that helpful, and I'll see you in the next video.